All right, so we're kind of starting, it's not something new because it still has to do with polynomials. So we've been doing multiplication. Yesterday we did the special scenarios. Today what's going to happen, or what's kind of going to happen the rest of this unit, is we're almost like doing the opposite of multiplication, which is going to seem kind of silly. But I want to review two of these multiplication things with just monomials, because that's kind of what you're going to deal with for the rest of the week, are just monomials. It's going to get a little bit more difficult next week, but you do have a quiz this Friday, and it's going to be over those multiplying special cases and this GCF stuff. So today and tomorrow you'll see some videos on how to do this. If you are still struggling, please make sure you reach out. I can try to explain it in a different way and see if that can help you. So we're going to look at 1 and we're going to look at 4. So for number 1, it says to find each product. So basically you're just multiplying, so you do that by distributing. So 4 times 8x squared is 32x squared. You multiply the numbers, add exponents if you were to have them. The 4 doesn't have one, so you're good to go. 4 times negative 5x is negative 20x. 4 times 7 is 28. And then leave it alone. Check and see if it can be combined or whatever, simplified, but it can't. Number 4, we have a number and we have a variable. So we're going to distribute. Zoom out a little bit on this. There we go. Now you can see. So 3 times 3d to the 4th times d cubed, we get 3. Add your exponents, d to the 7th. 3d to the 4th times negative 5d, multiply your numbers, add your exponents. 3d to the 4th times 6, multiply your numbers. d to the 4th has nothing to combine with, and then leave it alone. Today, what you're going to do is actually kind of the opposite of this. We are going to be trying to figure out these numbers on the outside, or with these variables and numbers on the outside. And if you take a look at like every term, what we're going to be looking for today is something called the GCF, the greatest common factor. So what the greatest common factor is, and this is, if the main thing you need to learn this unit is this greatest common factor, because it's going to keep popping up every section. So what the greatest common factor is, it is the largest number and variable, or variable, I should say, or variable, because sometimes they don't have variables in common, that all terms have in common as a factor. So, like for example, when you're thinking of factors, you're thinking of numbers that divide evenly into. When you're thinking about variables, it's a little bit more difficult. I think that after today and even tomorrow, the variables will get a little bit easier. So like for example, if I gave you the numbers 12, 20, and 24, and I asked you what's the greatest common factor between 12, 20, and 24? What you ask yourself is, what is the largest number that divides evenly into all 3 of those? I give you a couple of seconds. What largest number divides evenly into all 3 of those? And the answer would be 4. 4 divides evenly into 12, 4 divides evenly into 20, 4 divides evenly into 24. And it's the largest number that actually does that. 6 divides evenly into 12 and 24, but not 20. So you've got to make sure it goes evenly into all of them. That's going to hopefully be the easier part today. The other thing you're going to look for is if you had x squared, x cubed, and x to the 4th, what variable with an exponent do all of these have in common? Well, this is 2 x's, this is 3 x's, this is 4 x's. They all at least have 2, so you would say x squared. So if you have all of the same variable, you always go with the one with the smallest exponent. So I'm going to hopefully help you out with that here, looking at a couple of examples. So we are going to today just find the GCF. That's it. So when you do this, first thing that I would do is identify, you're going to kind of do this in parts, the GCF of the numbers. So first off, let's look at just the numbers, find the GCF of that, write it down. Then, after you've found the GCF of the numbers, you're going to identify the GCF of the variables. And again, that's looking for, do we have a variable that's all the same? Write the smallest exponent with it. So let's start here, number 5. I'll even switch up colors to keep it interesting for you. So we need to find just the GCF of these polynomials. So first thing, identify the GCF of the numbers. So I have an 8, a negative 24, and a 16. What is the largest number that divides evenly into an 8, a 20, or negative 24, and a 16? The largest number is 8. 8 divides evenly into 8. 8 divides evenly into negative 24, and 8 divides evenly into 16. Then you have to identify the GCF of the variables. So I have x cubed, x squared, and x. So since they all have x's, you go with the smallest exponent, and we have an x. So 8x is the GCF of that polynomial. So take a look at a couple more. Maybe once we get going on these, you'll see the pattern of how to do these without having to like break them up like I did. So step 1 for number 6, identify the GCF of the numbers. We have a 15, negative 5, and a 30, or just think of it as a 5. We're not going to worry about signs right now. We will in a minute, next week. So we have a 15, a 5, and a 30. The largest number that divides evenly into all of those is just a 5. Basically, you look for the smallest number that, like this 5 right here, what number divides evenly into the 5, and you just kind of hope that it goes into those as well. Same is true kind of for the exponents. You find the smallest one and make sure that divides evenly into the others as well. So we have a 5, and then we look at our variables. We have a c squared, we have a c. There's no c here, so it's just 5. If you don't have all of the terms with the same variable, you cannot put a variable with it. So just 5. Number 7 here. Identify the GCF of the numbers. I have a 9, an 8, and a 3. The largest number that divides evenly into all of those is a 1. That's it. 1's the only thing. Because they're all, well, 3, it's only a 1 and a 3 that divides evenly into it, and an 8, obviously, that won't work. So then we look at our variables. We have f to the 6th, f to the 4th, f to the 2nd. They all have an f. Go with the smallest exponent, so 1f squared. Or you could just write this as f squared, because if you write just an f squared, we know there's a 1 in front of it. Last one. Let's look at the numbers. We have a 32 and a 16. The largest number that divides evenly into a 32 and a 16 is 16. Now we're going to look at the variables. Now this one has multiple variables, so we're going to look at the letters separately. So we have g to the 5th and g to the 4th. So they both have a g. Go with the smallest exponent, g to the 4th. Then we go to the h cubed, h squared. They both have h. Go with the smallest exponent, h squared. So 16g to the 4th h squared. And you would just smush it all together. So today we're just finding the GCF. Tomorrow we're going to find the GCF and then do something with it. So please make sure you're practicing these and reach out if you have any questions, and we will chat tomorrow.